Now, we've got rational expressions under our belt. Let's try complex rational expressions. So what do I mean by that? This is when you have a rational expression, let's say A over B. I should have moved that over a little further. Let me grab it. Nope. Grabbing everything except what I want. There it is. Just need a little more space for that. A over B over C over D. This would be a complex rational expression because it has a rational expression in the numerator and it has a rational expression in the denominator. Complex. Well, let's start by just practicing with some numbers and what we know about fractions. So we're going to look at, the numerator doesn't need much attention, does it? We're going to look down here. And of course we notice we have unlike fractions. We want to make them have the same denominator. So the least common denominator here would be what? 4. 1/2 is the same as 2/4. So we've got 2/4 plus 3/4. That we can deal with. So we've got 1 divided by 5/4. Now that I have a fraction divided by a fraction, well, I know 1 doesn't look much like a fraction, does it? I can do that to make it look more like a fraction. Fraction divided by a fraction, we stay the same with this one, 1, and we go from divided by 5/4 to being multiplied by the reciprocal, 4/5, giving us an answer of 4/5. How about this one? I could just go to stay, change, flip, couldn't I? This is the same as 2/3 divided by 4/9, which if I stay the same with the first one, 2/3, change from division to multiplication, and take the reciprocal, 9/4. Then I have 2 times 9 over 3 times 4. Before I do the multiplication, it might be good to see if I can find any common factors. Makes my multiplication a lot easier. I do. I have 1, 3 by dividing both of these by 3, and in this case 1 and 2, giving me an answer of 3/2. Now let's see if we can recognize when we have a rational expression. Is this a rational expression? Well, almost. Yeah. What if we write it as 1/x? Then we certainly recognize that as a rational expression. How about this one? 1/a to the 3rd power. Remember that when we're looking at exponents, if you move the whole expression to the denominator, you can change the negative in an exponent to a positive. All right, so yes, this is a rational expression. Is 2 a rational expression? Yes, it is. Is the square root of 2 a rational expression? Well, the closest I can get to making it a rational expression, let's see. I have to say no, because I'm looking for a polynomial over a polynomial. And polynomials only have positive integers as their exponents. This is not an integer. How about x to the minus 2? The answer here is yes. Now, if I were asking whether or not these were polynomials, the only one that would be a polynomial is this one. This one is not a polynomial, this one is not, this one is not, and this one is not. But when I ask whether or not it's a rational expression, which allows us to have the polynomial in the denominator, then all of a sudden I get all these yeses. Okay, here's a good complex expression for us. What do we need? We need to have like terms. They have to have a common denominator. So my 2, if I multiply that by a over a, then in my numerator I will have a fraction with a common denominator. In the denominator, same thing. I'll multiply it by a fancy 1. Now I've got 2a minus 3 all over a divided by 5a plus 1 all over a. And rather than divide, I can multiply those. I stay the same with my numerator, which is 2a minus 3 over a. I change from dividing by this fraction to multiplying by it. And I take the reciprocal, which is going to be a over 5a plus 1. What happens? I've got a over a, which is the same as 1. So when I simplify this, 2a minus 3 over 5a plus 1. Is there any further I can go with this? Do I have anything common that I could factor out? I don't. This is as far as I can go. Remember that when you are simplifying, you cannot simplify terms. You can, and terms are when you've got something added to something else. You can only simplify when you've got factors, where you've got a product, things being multiplied by each other. Wow, this one is a little bit challenging, I think. Let's look at our numerator. We've got 1 plus, I'm going to leave 2 in the numerator because that's okay. This negative 1 is only applying to x. I want positive exponents, so I move it to the denominator. And then I've got 3 plus, I know we're not showing the 1, but we know it's there. Now I've got something to work with. We're going to have a common denominator of x, so it's going to be x over x plus 2 over x, or I'll go right to writing it as x plus 2 over x. And then I'm going to have this multiplied by x over x, so I'll have 3x over x plus 1x over x. They're both over x, so I can write it as a common denominator. Then I'm going to stay, change, flip. X plus 2 over x stays the same, changing from dividing to multiplying, and then flipping, taking the reciprocal, 3x plus 1. And you see a simplification opportunity right here. X over x is going to simplify to 1 over 1, and we have x plus 2 over 3x plus 1. Again, at this point we look to see if there's anything we could factor out that would be common to both these terms and both these terms, and there is no such number. Complex fractions.